Okay, good morning class. So today we're looking at the paper you guys have written. Yesterday we got up until question 5 point. The next page already. Did we do this one? Okay, that was the repeated one. All the way down. As we said, there was a couple of good questions in this paper. Yes. So yesterday we spoke about question 5.1, 5.2. In 5.2 we were required to determine the x and y intercept of M, which was the hyperbola graph. And again I'm going to take this off so that I can have space there and keep the equations in focus. So in question 5.3 we are asked to sketch the graphs of M and K on the same set of axes. Okay, so let's go. So that is your y, x. That's your exponential function for K. So the first thing we draw in is our horizontal asymptote, and y is equal to -1. Then you're going to cut your x and y at 0. Okay, so what do? We let x equal 1 to generate another point on this graph. So K of 1 is equal to 3 to the 1 minus 1, which is 2. So the other point is 1 and 2. So if x is 1, y is 2, so it's approximately there. So it's 1 and 2. As you can see, it's an increasing exponential function. Okay, and that is the graph of K of x. Then we have the hyperbola graph. We've got the horizontal asymptote at y is equal to -2. So that is 1 unit lower than that. Okay. And the vertical asymptote at x is equal to 1. Which is this one here. So x is equal to 1. It's positive, so it's in the first and in the first, yes, in the first and third quadrant. So it's going to be, if that is 1, 5 over 2 is approximately here, which is 2.5. So the graph is coming close but does not touch. Okay, and this is the graph of M of x. And of course, if this is -2 here, -5 will be approximately here. Okay. So we have two equations, we have two graphs. So in 5 point, I'm going to write here what the equation is. So that is K of x is equal to 3 to the x minus 1, and N of x is equal to 3 over x minus 1 minus 2. So let's see what 5.4, 5.5 I have in store for us. So in 5.4 the question says, write down the range of K. People, what is a range? Range is all possible y values. So if you look at this, the range of K is a graph in black. So does this graph exist at negative infinity? No. Where it starts existing at? From 1 onwards. Not so. So y has to be, -1. So y has to be greater than -1. Are you all okay with that? Alright, let's look at 5.5. The question says determine the equation of n of x. If n is the graph formed when m of x is shifted 2 units to the left. So we are told that m of x is shifted 2 units to the left. 2 units to the left, so I must plus 2 on the x. So because it's m of x is defined as that thing. So it simply becomes y is equal to 3 over x plus 2 minus 1. And remember, it's the additive inverse. And 5 units down. So you're shifting 5 units down, so it's -5. So it's minus 2 minus 5. So this equation is going to be y is equal to x plus 2 minus, no, x plus 1 minus 7. X plus 1 minus 7. Okay? And they're speaking about n of x. So n of x is equal to 3 over x plus 1 minus 7. Yes?
The other two is n of x is equal to 3 over x minus 3.
Shifted 2 units to the left. So if it moves to the left, I must add on the x. So now you guys can check your scripts again. If you had written that there, you should get the mark for it. Okay. You all agree with that, or you determine the equation of n of x if n is a graph formed when m of x is shifted 2 units to the left. It's the additive inverse. It will always be the additive inverse on your x. And 5 units down. So that is a mistake there. Okay. Okay. People, let's carry on with our lives. We're going to question 6. We are given that f of x is equal to x squared minus 2x minus 15. Determine the coordinates of the turning point of f. So I'm just going to write the equation here. F of x is equal to x squared minus 2x minus 15. 6.1.1, determine the coordinates of the turning point. People, how do you calculate the coordinates of the turning point? Minus b over 2a for the axis of symmetry, which is the x value of the turning point. So it's going to be minus minus 2 over 2a, which is going to be 1. So we now say f of 1 is equal to 1 squared minus 2 times 1 minus 15, which is minus 16. So the axis of symmetry, or the coordinates of the turning point, is going to be 1 and negative 16. Let's look at number 2. Number 2 says the x-intercept of f. How do you calculate x-intercept? We let y equal to 0. So 0 is equal to x squared minus 2x minus 15. So we got x and x, 5 and 3, minus plus. So x is equal to 5 or x is equal to negative 3. Okay. 6.1.3, the question says determine, or they will give the range of f. So again, is this graph smiling or frowning? It is smiling. There's a minimum value. Not so. There's a minimum value of negative 16 occurring at x is equal to 1. So what is the range of this graph? What is the range of this graph? Y must be more than or equal to negative 16. Must be equal as well. Okay. That is number 3. Number 4 asks you to sketch the graph. So I'm going to take some of the stuff off here. So that is your x-intercept there. The turning point was determined as well in number 1. We don't need the range. We don't need to know the range for us to, in order for us to draw the graph. So I'm going to take that off in the sketch. Okay. No. Stop. Okay. So remember, in our mind's eye, the graph is smiling. Okay, this is 6.2. The graph is smiling. Is it 6.2? You see the question better? Oh, I see. Yeah, we are given in question 6 that f of x is equal to. Okay, now it makes sense. So 6.2 they asked you to sketch the graph. So let's go. So remember in our mind's eye the graph is smiling, it has a minimum value. It's going to have an x-intercept at -3 and at 5. There's an axis of symmetry at x equal to 1, which happens midway between the two x-intercepts if there are. X is equal to 1. And on 1 it turns at -16. The -16 is approximately there. And we draw it from our turning points in that direction without the use of a ruler there. Okay, we drew it freehand. Okay, so also we can work out our y-intercept. How do you calculate y-intercept? We let x equal to 0. So f of 0 is equal to -15. So my y-intercept here is -15. And importantly, we draw in our, we write in our coordinates of the turning point, which is 1 and -16. Okay. This is x is equal to 1. Okay. In 6.3, the question says determine the average gradient. So for the average gradient, I need to know the formula. Then you need to know the average gradient between x is equal to 2 and x is equal to 6. Do we have a point of 2 here? No. So how do we work out the average gradient? Same as gradient twice. Not so. So f of 2 is equal to 2 squared minus 2 by 2, which is -2 minus -17. Is that correct? -15. You're absolutely correct. Okay. I'm wrong there. -15. F of 6. Then I give you 6 squared minus 2 by 6. 36 minus 12 is 24. Minus 15 is 9. Is that correct?
Yes, sir.
9. Alright, so the points it's going through is 2 and -15 and 6 and 9. So for the average gradient, we say it's going to be f of b minus f of a over b minus a. It's the same as x1 minus y2 minus y1 over x2 minus x1. Okay. So if this is a, that's of course f of a. If that is b, this is of course f of b. So it's going to be 9 minus 15 over 6 minus 2. 9 minus 15, 9 plus 15 is 24 over 4, which is 12. 6. How do I get 12? 2. So 6. Thank you. So the question says in 6.4, explain your answer to question 6.3. What's your answer here? The graph is increasing. So between x is equal to 6 and x is equal to 2, the graph is increasing at a rate of 6. Okay? That's all you need to write there for your 2 marks. Okay, and then the last question in 6.5, we are told for which values of x is f of x increasing. So the parabola will increase if and only if we moving from as x increases in that direction, the value of the graph must also increase. So as you can see here, coming from the left, the graph is increasing or decreasing? Decreasing till 1. Not so. On the other side of 1 is actually increasing. So where's the graph increasing? Is increasing for x's greater than 1. And that's the answer to 6.5. Okay, that's the answer to 6.5. Okay, any confusion here, people? No? And that basically brings us to the end of this paper. Is that correct? No. Alright, let's look at this bonus question quickly. We are told that if 9, let's just make this a bit bigger. If 3 to the 9x is equal to 64 and 5 rational exponent the root of p is equal to 64, calculate the value of. Okay, so firstly, here we can see that's the square root of 5 there. Okay, so if I square root both sides, then that would be the square root of 5 root p is equal to 8. If I introduce square root, of course, plus minus here. Okay? So we're just going to consider the positive parts here. As you can see, the base of 5 is positive. There's no way that can be negative there. So it has to be positive. Okay? Then, so this denominator is simply 8. Okay? Let's look at the numerator. We need to get 3 to the x. So this here, the numerator can be written as 3 to the 3x minus 3. That's when I multiply the exponents out, which is 3 to the 3x times 3 to the minus 3, and that is all over 8. So I need to know what 3 to the 3x is. Not so. Now coming from here, if I take the cube root of 3 to the 9x is equal to the cube root of 64. So the cube root 9x over 3 is going to be 3 to the 3x is equal to cube root of 64 is 4. Not so? So this the 3 to the 3x is 4. So it's 4 times 3 to the negative 3 over 8. So 4 going to 4 once, 4 going to 8 twice. So it will be 3 to the negative 3 is the same as 1 over 3 cubed times 2. This is 27. 2 times 27 is 54. The answer is, that they're looking for is 54. Alright. That brings us to the end of paper 1.